We've been talking about dividing complex numbers, imaginary numbers, using the conjugate, but we can actually do the same thing with just regular square roots. We can rationalize a denominator with a conjugate but keep the minus in the middle. In other words, what I'm saying is, if we have a plus b times a minus b, where there's no imaginary part, it's going to be a squared minus b squared. Remember, with imaginary numbers, it became a plus in the middle because of the I squared. We're not going to have that now, so it's going to stay as a minus. But other than that, it's going to be exactly the same concept. So if I want to rationalize the denominator on 5 over 3 plus 2 square roots of 7, all I have to do is multiply this by the conjugate 3 minus 2 square root of 7. And that's going to make the denominator into a rational number, a whole number. Doing the same thing to the top with 3 minus 2 square roots of 7. And then multiplying it out, we'll distribute the 5 to get 15 minus 10 roots of 7 over, and then in the denominator, I know it's going to square the first term to get 9. We'll put a minus in the middle because we have real numbers. 2 squared is 4, and the square root squared is just going to leave the 7. And so we can simplify this. 4 times 7 is 28. And so we end up with 5 minus 10 root 7 over 9 minus 28, which is negative 19. With radicals, you can express the final answer as a fraction, or you can distribute the divide by negative 19 through to get negative 5 over 19 plus 10 over 19 root 7. Both of those work. It's more required with imaginary numbers to do that. So generally, you'll see with rationalizing the denominator, we're going to leave it as the fraction form when working with radicals. Let's do one more example of rationalizing the denominator. Let's try 10 over 5 plus 7 root x. Again, if we want to get rid of the radical in the denominator, if we want to rationalize the denominator, we'll multiply top and bottom by the conjugate, which is 5 minus 7 root x. Top and bottom. Distributing through on the numerator, then, is going to give us 50 minus 70 root x. In the denominator, we're going to square the first term to get 25. Keep the subtract in the middle. 7 squared is 49. And the square root of x times the square root of x leaves just x. And because we can't do any factoring or reducing here, that's going to be our final solution. That's how we can rationalize the denominator, but it's actually also possible to rationalize a numerator. If I want to rationalize and get a whole number on the top, we can do so in a very similar way. Let's look at 5 plus the square root of 8x over 6. This time I want to rationalize the numerator, the top number. So to do that, we'll multiply by the conjugate of the top number, 5 minus square root of 8x. Same thing on the bottom to stay balanced. We know in the numerator, then, that's going to give us the numerator squared, 25, minus the square root of 8x squared is 8x. In the denominator, multiplying the 6 through, I get 30, and minus 6 root 8x. And now we have a rationalized numerator where the numerator does not have a radical in it. So you can rationalize the denominator, or you can rationalize the numerator. Both are done with the conjugate, the same conjugate we saw from those imaginary complex numbers. It's now your turn to practice some of these, so take a look at the assignment and let your instructor know if you have any questions.